In this video, I'm going to explain Cauchy's rules of limits. So the basic algebraic knowledge led us to some straightforward rules, which is called Cauchy's rules. So I'll just start with a small example. So if we have limit x approaching to 4 of 2x plus 1, so what we do, we simply first plug in the value of x and see what we get. So when we are doing this, essentially what we are doing is we are splitting the limit over different parts of this function. So those rules are called Cauchy's rules. They're quite intuitive, but I'll just explain them in detail today. The first rule is for a constant y equal to c. So let's say y is equal to fx, which is our function. So for a constant y equal to c, limit of x approaching to a of c is equal to c. So let's say if you have let's say if we have y is equal to 7, so that's our function, and then limit of x approaching to 2 fx would be limit of x approaching to 2. The function is 7. So since it's independent of the value of x, we get just 7 in the end. So any constant function has a constant limit. So you can think of this function as, so y equal to 7. So the value of the function remains constant. So y equal to 7. So no matter what the value of x is, the y value is always going to be 7. The next rule is for a linear function. So if you have fx equals to x, so limit x approaching to a, x would be a. So this and this are same because we just plug in the value of x. So this is our linear function. So for example, if we have y equal to x and we try to find limit, what is the value of fx as x approaching to 100? So in that case, so our function is x, so we just get 100. So it's the same value as a. And in this case, we can think this of as our function y is equal to x. So if you have x value 100 or 5 or whatever you have, so the corresponding y value is gonna be essentially the same. Next, we discuss the Cauchy's rule for if you have a power function y is equal to x raised to power n. So again, we simply plug in the value of x. So limit, so you just plug in this value here. So we get, for example, if you have y is equal to x cube and you try to find limit as x approaches to 2 of x cube, so we just replace x by 2 and we get our solution. So next rule is if you have a constant multiplied by a function, so you can take the constant outside the limit and then just take the limit of the function. For example, if we have limit x approaching to 5, 3x square. So 3 is independent of x. You can just take that out and apply the limit to your variable part. So 3 times 5 square, so 25 times 3, which is 75. Next, we have the addition subtraction rule, so which states that if you take the limit of addition of two functions, that is equal to the sum of individual limits. Similarly, if you have limit of subtraction of two functions, that would be equal to the subtraction of individual limits of the functions. So for Alright, so in this case we get 2 minus 10 over 2 plus 5 over 2 square. So overall we get negative 1.75. So limit of sum is equal to sum of limits. The next rule states that the limit of product is equals to the product of limits. So for example, if we have limit as x approaching to 3, x plus 1 times 2x plus 1. So here we have product of two algebraic expression. So implicitly we can just take the limits and then just multiply the value of the limits in order to get the overall value. So in this case 3 plus 1 would be 4 and 2 times 3 plus 1 would be 7. So we get 4 times 7, which is 28. So these are all Cauchy's rules of limits. So next we're going to try to do some examples and see if we can solve these problems by using the rules. So let's try to first find limit x approaching to negative 1 square root of x squared plus 8 over 2x plus 4. So we can just apply the Cauchy's rules. So it means you can take the limit of x squared in under the square root. So negative 1 square plus 8. I'm just going to plug in the value here. And again, x is negative 1 plus 4. So on the top we get square root of 9. On the bottom we get 4 minus 2, which is 2. So we get 3 over 2. Alright, so good enough. So that is our value of the limit. So we got a finite number. So let's try the next one. So in next one we have square root of x minus 1 over x minus 1. So if I try to use the Cauchy's rules and I plug in the value of x here, so I replace x by 1, so what we get is 0 over 0 form. So it means it doesn't work here. So it means either we need table or we need the algebraic method to solve it. So we need to do some algebra before we can actually plug in the values. All right, let's take a look at the next one. So again, in next one, so I'm going to plug in the value. So x is approaching to infinity. So if I plug in infinity here, so we got a really, really large number on the top and on the bottom. And again, this is an indeterminate form. So we cannot just simply plug in the values and solve it. So we need table method or we need to do some algebraic manipulation here. So what we learned from these examples is while solving the limits, while solving the limits, we can, the step one we can use is, step one is, so use Cauchy's rule, means plug in the value, so use Cauchy's rules to find the limit. So to determine the limit, but if there is a problem, so then we need to use table method or algebraic manipulation. So we can use table method or algebraic manipulation, and then we can plug in the values again by using Cauchy's rule in the end. So in the next video, I will explain algebraic method in detail.